Welcome to calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
This is another example where we have two functions but no bounds. So we have to know what these look like. So we're going to create a sketch. This is a parabola, concave up, shifted down 1 unit. Now, what are these points of intersection? We may need them, so let's solve them to the side here. Now we have to look at 2 times cosine of x. Now, the cosine of x, the parent function, starts at 0, 1, but because it's being vertically stretched by 2, what that tells me is it's actually going to be stretched up to 2. So I'm just going to say this is 2, and then the function comes down. Now, what I don't know, though, is it going to be more or less than 1? The parent cosine function does something like this. Now, pi over 2, if we do pi is 3.14159, and we divide it by half, then we're going to get something that is greater than 1. So this tells me my cosine function is going to come down someone like this. It's going to come out past 1 and past -1 because cosine is symmetric to the y-axis. The area or the region that it wants is this. So we need to know these points of intersection. Now, in a previous example, you saw we were able to calculate those by hand. We can't do that here. We're going to need to use a calculator for this one. So what we're going to do is we're going to graph this, and then we're going to calculate using calc those points of intersection. Now, even though one of my functions is not a trig function, I still want to go zoom trig. So I can see there it is. So what I'm going to do now is I'm going to adjust my x-axis to make it a little bit smaller so it's a little bit easier for me to calculate those points of intersection. Next, I need to calculate the point of intersections. Now, we're not going to use the trace button for that. We need to know the x values only because that's going to give me my bounds. So we're going to go second, and then we're going to activate the calc, so that's the trace button. And we're going to select intersect. So now it's going to ask you which is which. So read the pictures up here. And so it's going to say y1 is the cosine. That's fine. So I'm going to move the cursor over here a little bit because I'm going to do the one on the right. Now it says, hey, what's the first function cosine? Not a problem. I'm going to press enter. Then it's going to say, what's the second function? It automatically is going to move the cursor to the second function, which is very handy. So now I'm going to press enter again, and then it's going to say, take a guess. As long as my cursor is kind of close to it, it's not a big deal. I moved it like almost on it. You don't have to do that. As long as it's close, it's fine. Press enter. It's going to calculate. This is my point of intersection. Write down all those digits. Now, I don't need the y value because remember, we're integrating with respect to the x-axis. So we're integrating from left to right. So all we need is the x values to tell us that because we're integrating horizontally. So just write it like this. Now, what's the other one? Well, if you remember your functions, cosine is symmetric to the y-axis. And the parabola is also symmetric to the y-axis. So this coordinate here, based off of symmetry, should be this same exact value, only negative. If you doubt yourself, let's calculate it again. Okay, so we have our two values. Now, if you notice, they're really close to each other. It looks like for some reason on the left side, it rounded that 3 instead of showing the 7. I'm not sure why it did that, but they're very, very close. So now let's set up our integral. So we're going from left to right. What is our upper function? What is our lower function? If we look at the rectangle here, we can see our upper function is the cosine function. And then the bottom part of it is the parabola. Now we're going to put this in our calculator to approximate our area.